Thank you, Alison. So yeah, let's first start by introducing ourselves. I'm Arjan. I'm a software consultant working for Xebia in the Netherlands, and I'm doing lots of coding also in my spare time. And next to that, I like cycling and beer brewing.
Hi, my name is Dan Yeaw. I'm really excited to give this talk with Arjan. For my day job, I work for Ford Motor Company, where I design safety into complex electrified and automated technologies. And in my free time, I've been working on this app with Arjan in order to model these complex systems using open source software. And I also like cycling like Arjan does.
So what are we going to talk about? It's about going multi-platform. So first of all, we ask ourselves the question, why do you actually want to bother? And secondly, we're going to give a brief introduction of our case, the modeling tool. And next we're going to see what we did for Linux, Windows and macOS. And lastly, there are some takeaways that well, hopefully you can bring to your own project. What, at least in our case, we're developing a software, and what we want is to have these apps to be useful for others. So people get value out of it, and even better, they are actually ready to contribute back to the project. And well, if you look at this chart, you see that actually the potential of doing that for a Linux-only application is, well, you're covering not that much of the potential user base. At best, for developer tools, it's roughly 25%. So, well, we were leaving out a lot of potential users by just staying on Linux. So that's why we made an effort to also cover the other desktop platforms. So what was our reasoning for going multi-platform? A broader and more inclusive user base. So not only people that are like-minded on Linux, for example, but also people with Windows and a Mac background. We think it can help people being introduced to open source. If you're on these other platforms, using open source tooling is not that much present. For us also, it's a sense of being future-proof. You know, we're not tied to this particular operating system, which also ties in with the fourth point. We improve the adaptability. People do not have to use Linux. So, for example, if you want to use this tool on your project, it would be a bit sad if you leave out your fellow teammates that are only using Windows. So, well, what are we targeting? The major desktop platforms. In doing so, we try to automate as much as possible. We're doing it in our spare time, and doing tasks by hand is labor intensive and it's really prone to error. And also, we don't want to scare away people with those scary messages that you nowadays have on Windows and macOS. So on to our use case. We both work on Gaphor, which is a modeling tool that supports UML, SysML, RAML. I hope I pronounced that right then. which is a risk assessment modeling language, and a C4 modeling language, which is a more simplified, more easily accessible. It's running on GTK, as you might see from the screenshot. It's written in Python, so it's roughly 44,000 lines of Python code. Of course, with the GTK bindings. And I started this project almost 20 years ago with the idea that it can bridge a gap between technical people and less technical people.
So about 4 years ago, I started to get involved with Gaphor as well. I was looking for an open source modeling tool that I could use to model these really complex systems that I talked about earlier. So for example, if you had a car that could park itself, we would design how the behavior and structure and requirements of that vehicle would all work together safely. And I stumbled across Gaphor, and I was really immediately blown away. It was really simple to use. And it was also using Python, which for me, I'm not a professional software developer, was a lot more accessible to me to kind of jump right in and get started. And unfortunately, at the time, Arjan had gotten busy with other projects, so the project hadn't been updated in a while. And we'll kind of talk over the next couple slides about how we brought it back up to be modern again. So next, we're going to discuss how you can set up your project for success with kind of these tips we learned the hard way. So when I first picked up the app, Gaphor had this docking widget called ETK docking. And it created an experience that you'd expect from like a complex IDE like Eclipse. So where it allowed you to rearrange and hide and maximize and pop out UI components. And that required creating some really custom GUI widgets in GTK2 in this case, and PyGTK, which were the Python bindings at the time. And although it was really clever, it would have had to been completely rewritten from scratch to move to GTK3 and PyGObject, which is the introspection library for GTK. And also, we were upgrading from Python 2 to Python 3 at the same time. Also, if you came across a bug or an issue, it was really hard to get it fixed because you are, I would say, exploring the edge cases of the GUI toolkit itself. And probably most other people haven't run into a similar problem before because you're really creating these very custom widgets. Here's a small example where we defined our own compact button. So the compact button's inheriting from the GTK widget, and it has a couple of class properties defined for the name and also the signals and properties. And they're defined in those double underscore definitions, or also called dunder. And the first one's the name, named it ETK compact button. And then there's two Python dictionaries that define the signals and the properties. So I guess reflecting on this, do users really need that much customization in their UI? And I think keeping things simple and consistent and aligned with the human interface guidelines is really the way to go, so that you don't have these like painful upgrades. GTK and Qt already provide this really great foundation to build GUI applications with. And in the same vein that you want to keep your GUI pretty simple, I would also try to keep your tool set small and simple as well. So try to keep to just a few libraries and make sure those libraries are well supported cross-platform. Here's an example for the dependencies of Gaphor. So you can see here that, of course, we depend on Python itself, and PyGObject provides the Python bindings for GTK. PyCairo is the canvas widget. And then we have two of our own libraries that we also support. One's called Gaphos, and it provides a diagramming widget, which allows you to draw shapes and relationships to the shapes. And generic is a generic programming or multi-dispatch, I guess, library that allows you to call functions or methods based on the type. And finally, recently, Arjan added CSS support for skinning the diagrams and customizing how they look. And so we depend on CSS too as well. This is one nice thing for us for Python as well, that batteries are also included, and you have most of what you need already to build even very complex applications. There are tools like Cookie Cutter, which help you fully create a new project from scratch using the best practices for things like testing and packaging already set up for you. That's a really big advantage. For Gaphor, we also use a more modern pyproject.toml to configure our project instead of kind of the more legacy setup.py. And we use Poetry for building the project into a wheel and then uploading it to the Python package index or PyPI. But there's also a few other tools like Flit and pip tools that are great as well. In other words, I recommend setting up your project based on the language you are using, their best practices, and then try to design a GUI that will conform to the GUI's interface guidelines. Packaging your app so they can be easily installed on each platform is a very challenging problem. Each platform really needs its own solution, and next we'll talk about some of the tips we learned along the way. I would say kind of the previous solution for Linux, and I guess maybe I'll pause and say, sorry, our emojis aren't showing up in the slides. That was a cool smiley face. Yeah, so some of the previous solutions were things like Deb and RPM. Are great solutions, but it also made it difficult for app developers to get the latest version of your app out to their users because it often required, I guess, people to upgrade their actual distribution to get the new versions. Flatpak and the distribution platform for it called FlatHub provide a great way to distribute your apps for Linux. I guess the format's really great because it sandboxes your app, it allows installation by non-root users, and also has really good desktop integration. One of the killer features as an app developer that we found was the maintained platforms called runtimes. And these really provide that strong foundation to package your app on top of with all the dependencies you need included. One of the challenges we faced with Flatpak was getting a reliable build script to work with Python dependencies. Flatpak uses a manifest file, which is a sort of recipe in JSON or YAML format. And among other things, the manifest has all of your dependencies for your app, including the download URL for it, and as well as the SHA-256 sum, the hash of the file. This helps ensures that the Flatpak build is reproducible so that you get the same result each time. And although there's a Flatpak builder tool for Python, it uses pip to re-resolve all of the project dependencies, and it defaults to using source distributions instead of the binary format that Python has called a wheel. We tried to use this for a while and even created a poetry builder tool that we upstreamed to the Flatpak builder tools. However, every time we went to go make a new release, something would break and we would have to troubleshoot for a while. And this is not really what you want from a release process. You want it to be simple and reliable and automated so you can just push out a new version to your users. So to fix this, we end up using a simple bash script. And what it does is download the wheel off of PyPI, that Python package index, with all of its dependencies, and then writes the download URL and the hash to the manifest. Here you can see in this bash script, we use pip to download the new version. We use find and awk to list all the dependencies we downloaded in and put them in two columns with a name and the name of the package and the file name. And then we use curl and JQ to hit the PyPI endpoint and get the URL and the hash so that we can put that in the manifest. Bash scripts aren't the solution to everything. In this case, it made our manifest generation really simple and reliable, and it has been great ever since. A second challenge is that FlatHub uses a separate GitHub repository to build all the packages. While it is great that everything is set up to do automated builds and publish to FlatHub, it also adds a little bit of extra complexity and maintenance because now your packaging is split between your main repo and the one that FlatHub provides. So next I'll talk for a minute about app image because it's another great solution. So after we had been supporting Flatpak for a while, we got a request from one of our users to create an app image, and I was a little familiar with it because I had downloaded app images for other Python apps in the past, and I always thought it was nice because you have this single file format that you can download and just run from there, and you don't have anything to install. One thing we did learn while packaging our app for app image was because there's no external dependencies, that also means for the developer, you can't rely on these runtimes or other dependencies being available for you when you go to build the app image. This does create some tension because I would like my app to be using the latest version of Python, the latest versions of the GUI toolkits and other dependencies. And because this is open source and I want to always be developing on the latest and greatest and keep things simple and more fun to develop with, and also probably a little bit more secure. Unfortunately, things like glibc aren't backwards compatible, so you should really build your app against an older distribution to maximize compatibility. Unfortunately, some of those older distributions then don't ship with newer versions of things like GTK. They're often 3 to 5 years out of date. There are tools to help with this and even Docker containers with the right dependencies you can use, but this isn't as straightforward as we would have liked. So for Windows, MSys2 provides a great environment for building, installing, and running applications in Windows. It has a bash command prompt, so a lot of you, if you're used to working in Linux, will feel pretty comfortable and right at home. It is also the recommended way to run a GTK application in Windows. And once we got Gaphor running in Windows, we used PyInstaller, which is a Python library, to bundle it with all the needed dependencies. However, this wasn't all smooth sailing either. Python and MSys2 has many patches in order to get it to compile against Ming W64 GCC instead of the default Microsoft Visual C++. That's what Python is normally built with in Windows. Since MSys2 is kind of a niche environment in Windows, Python and most of the libraries aren't very well tested in it, and it is common for things to break. We were able, though, to contribute upstream and get pull requests merged to projects like VirtualEnv for the virtual environments, PyInstaller, and Poetry to fix bugs and improve compatibility. Although this, yak shaving isn't directly making our app better, it does improve the overall ecosystem for others to make use of it as well. I hope we can eventually get some of these downstream patches to Python pushed upstream as well. After feedback from our users, we also did implement code citing in Windows. In Windows, users were getting those kind of scary messages saying, hey, this app that you download is not safe to run from the internet. This does involve paying a couple $100 a year on a code signing certificate and was a little bit of a foreign experience for us, but it was pretty easy to integrate it with our continuous integration build process. Here you can see the sign tool that ships with a Windows SDK, signs the application using the certificate. A timestamp server that's with that TR, and also TD and FD provide the timestamp and the file digest using the SHA-256, and we're able to integrate that with our continuous integration for the app.
So that kind of brings us to the last platform, which is macOS. On macOS, we kind of have a similar-ish situation to Windows, but not that bad because macOS under the hood already has a BSD-like Unix environment, BSD Unix environment, and there is a project called Homebrew, which you can use to install all sorts of open source dependencies, and this also includes GTK, which is really fortunate for our effort to make it running on macOS. And next to that, of course, we also have to deal with the code signing. On macOS, for those who are not really familiar with it, you build an app which is kind of like an app image on Linux, as Dan explained. It contains files with a particular starting file, which is the info.plist, and from there basically the whole application is started. So the app directory contains everything, our application, but also the dependencies that we use that are not native on macOS, such as GTK. Next to that, it's common to distribute this app in a disk image, which is something like, well, you can think of it like an ISO image. It's a read-only image that that basically packages the application. And you can set the background in it, and it give it a nice appearance when people first start, downloaded it and start it up. One thing that we had to deal with, which is quite different from how it works on Linux, is that library references are all absolute. So if you compile something against a certain library, that library should be is in a particular folder on your path, and you should not move it because then stuff breaks. In order to get it in the app folder, however, you need to copy it over, and there are some tricks. You can do some renaming to make sure that, for example, the library is not absolutely referenced, but is referenced relative to the executable binary, which in our case is the second file in this example, the macOS Gaphor file. Thirdly, there is some work that has to be done with environment variables, so that, for example, font config works, the XDG directories are set properly, and stuff like pixbuf modules are loaded as you would expect. We used to use our own script for that, which was again a nice, I said it, piece of bash magic. However, at some point when the Mac of the Windows build was working properly, it proved to be quite easy to also do the build for macOS with PyInstaller. So that's what we moved towards, and actually we never looked back. It saves us a lot of maintaining, because what we used to have is that with every big update, even on Homebrew or on macOS itself, we needed to revise our packaging script because something broke. And now with PyInstaller, we haven't had that problem since. And lastly, then, there is the signing to avoid the scary messages for users. So Dan is actually an official Apple developer nowadays, so that we can sign the application. And just like Windows, everything is performed in the build pipeline, which saves us quite a bit of work, actually. Because for the signing, we need to sign both the app, so the .app folder and everything in it needs to be signed. And once that's done, it can be packaged in the disk image, and that also has to be signed. So you can imagine what that would be if you would have to do that for every release by hand. Here at the bottom, I pasted a little screenshot of what it looks like when we do an average build. This is just something that I picked from well, quite recently. I don't know where it was. It was not a release build that you can see by the version names. And what you can see is that everything, like the app image, the macOS image, the two installers for Windows, that is the pure Python executable, and there is the Python executable, the source code. What we learned from all of this is that we should approach each platform separately. Initially, we had, well, actually, our first platform that we supported was macOS, and only after that we implemented Flatpak. Then came Windows, which allowed us to revise macOS, and after that the app image. So the order in which things happened was not the order in which we explained them. What also helped a lot was to work with upstream projects, especially ironing out issues. For example, in PyInstaller, it saved us, well, nowadays it saves us a lot of hassle. And well, we integrated everything in the build pipeline. So when we do a release, basically nothing special happens except from that the version number is not a dev version, but is a release version. Well, this kind of takes us to the end of our presentation. I see no questions in the shared notes so far.
We are excited to answer your questions if you have any.
Obviously. What about security? What do you mean security? As part of the, I don't know if this answers your question, but Flatpak applications are started in a container, basically kind of a containerized environment. And as part of the manifest, we provide some, well, we request some permissions like access to the file system. And that is taken care of in the Flatpaks. And I think if you install them, the Flatpak will ask you for permission or your consent on the permissions that the application is asking for. Does that answer your question?
So looks like the next question is, have you experimented to use Flatpak on Windows with Windows subsystem for Linux 2? So we haven't experimented with that, and it's because I think mostly our build environment is at MSys 2.1 and not Windows subsystem for Linux. I guess I've seen recently that Windows subsystem for Linux is actually able to run GUI applications as well. So maybe in the future there's some potential there where you could actually use Windows subsystem for Linux to package your GTK app for Windows. But we haven't experimented with that yet. We're still using MSys 2 for our packaging.
Yeah, to my knowledge, the GUI support from WSL is experimental still, so it's not a mainstream feature. What are you missing most on FlatHub from a developer perspective? Well, I think that Dan pointed that out, kind of, is that we have our Flatpak build currently in a separate repository. So it means that we have to kick off a separate build to actually perform the Flatpak build. And it would be really nice if we could integrate that with our mainline, so that we, for example, also can do nightly builds from Flatpak. We call them nightly, just every commit. Create a fresh build for Flatpak for everybody who wants to be cutting edge, which is probably Dan and me.
So the next question is, how is the build pipeline built? What software or services compose it? So our project is using GitHub, although there's lots of other good alternatives like GitLab as well. So we are using GitHub Actions, and actually we iterated a few times on that as well. We were used a few different services over time, but eventually when GitHub Actions was released, we started using that. It is nice because some of the actions are reusable, so you don't have to figure out, say, how to check out your code, how to sign an app, all those different steps. You can just grab an action that's already been developed, and it does a lot of the work for you, which is really nice. And we make use of other things, other automations, like to label our PRs and automatically create our news for release. And we also use things like Dependabot, which automatically bumps our dependencies when new versions are released. And every time we commit or merge a PR, it runs the full build, including what Arjan showed for the packaging the app. And so we can test it at every build instead of only when it gets released.
Yeah, ever since we haven't made any RC or alpha releases anymore.
Yeah.
We just stopped doing that. I just. Next question: did you consider using Qt or Qt Quick? Back in the days, but then I have to recall going back like 20 years. I choose GTK because it was, well, first of all, the GIMP was built with it, which was a quite impressive application, especially 20 years ago. So I thought if it's good enough for the GIMP, it's probably good enough for me. And next to that, the license of Qt is backed by a company, and GTK was purely open source. So that was one of the more idealistic reasons why I took GTK. And I don't know if I would have been better off with Qt. I think Qt has a lot more features, so that's definitely what by choosing GTK I missed out on.
I think in general we like GTK pretty good though as well, so I don't think it was like a bad choice, Arjan. So yeah.
Well, and one of the things back in the days, I'm just trying to recollect my memory here a little. Back in the days, GTK was quite strong on the language bindings. As far as I recall, better than Qt at that point. So that was because I wanted to develop it in Python. That was one of also one of the reasons why I took GTK.
So the next question is about where do we keep our signing key for Mac and Windows? Is it on the build server or do you inject it into the build task? So the signing key is kept in GitHub a secret. So you add a secret to your repository, and then that secret's all encrypted, and then the build pipeline has access to the secret. If you're doing a build from the main repository, so people who are maybe fork the repo or creating a PR don't have access to the secret. And then depending on what type of signing key is, we convert the format from the secret into the right format during the build and use it like that.
Actually, I don't think I even have access to those keys.
No, it's really a secret then, huh, Arjan?
Yeah, it's quite secret. But it's quite charming, so I'm not complaining. 7 is a comment about FlatHub. I also face this issue of split repositories. Oh, that's more like a comment. Okay. Okay, well, we'll check that out. Thanks for the suggestion, George. Do you plan or are you moving already to GTK? Yes. We started moving to GTK 4. So far, the experience has been good. Good. We can keep both GTK 3 and GTK 4 support running, and it is important for us, because if we to switch only to GTK 4, then we definitely need to, well, it will be one hell of an exercise, because we also have to rework all the packaging for all the platforms all in one shot. And well, our time is precious, so I'd rather do it in small steps. So I'm currently we're working on getting support for both GTK 3 and GTK 4 in the application.
I think Arjan's just waiting for my pull request review, and then we'll have GTK4 support, right?
Yeah, then it's kind of like it starts and it does something, but
Yeah.
there are of course still issues, but we can fix those as we go along. What desktop setups do you use personally for developing the app? I'm currently running Ubuntu Linux, stripped pretty much all the Ubuntu stuff. And I'm using Visual Studio Code as my editor of choice nowadays. How about you, Dan?
So I'm using SUSE Tumbleweed. Converted not that long ago, maybe like 6 months ago. I used to use Ubuntu. I like it. It's really nice. I normally use PyCharm as probably the main editor I use, although sometimes use Vim and other editors occasionally as well. And then I guess the rest of the Python ecosystem we use as well, as far as the developer tools.
Yeah, and I have actually been working on this application also for a long time on macOS. For the last 2 years, I've switched to Linux, but before that, I helped Dan by doing it by building it on macOS actually. So
yeah, I think if you couldn't tell from the presentation, I normally handle a lot of the Windows stuff, and Arjan normally handles a lot of the Mac stuff, and then we kind of work together on the Linux thing. So.
Yeah. Cool. So if there are no more questions, then I think we can wrap it up and give Philip the floor.
Yeah, thanks everyone.
Thanks a lot.